Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss fuel cell. Last class I have started batteries. In that I have discussed Leclanche cell, also called dry cell, and other cell I have discussed, that is the mercuric cell. These two cells comes under the primary cell, and in secondary cell I have discussed lead storage battery, and second I discussed nickel cadmium cell. Here this in a lead storage battery you should know little more, because this lead storage battery is used in almost all vehicles, two-wheeler also, four-wheeler also, truck, and many vehicles they are using this. Then here little more you should know about the voltage. Actually, how much voltage it will produce lead storage, that I am telling you. It depends on voltage, depends on concentration of H2SO4. Question is asked. H2SO4 is used in lead storage battery as electrolyte. Already I discussed. Then voltage depend upon concentration of H2SO4. If suppose at 25 degrees centigrade normal temperature, if H2SO4 concentration is 7.4%, then it will produce 1.9 volt, 1.90 volt. And if its concentration is you can say roughly 3 times, means 21.4%, then its voltage will be 2 volt, means 2.0 volt. And if its concentration is 39.2%, then its concentration will be 2.14 volt. Means this is concentration dependent of electrolyte. How much voltage it will produce, that depends upon concentration of electrolyte. And you have seen during the reaction that when it will be discharged, means when it is in use, it produces water also. Okay, means lead oxide plus 2H2SO4, it produces lead sulfate plus 2H2O. This is during discharging, means by using, when you are using, and during recharge reaction will be reversed. Okay, and here main application I am telling you, that each electric pair develops a potential of 2 volt, roughly 2 volt, 2.14 I told you, at 39.2%. And if it is you can say electrolyte is this things 38%, suppose, then slightly it will differ. Then generally it is used around 39.2%, so that it can get maximum voltage. Then each electrode pair develops a potential of 2 volt. In order to obtain higher potential, a number of electrode pairs are connected in series. Many pairs of electrodes are connected in series to get the more potential. Lead storage batteries are extensively used in automobiles to start the engine. They are also used for electric supply in telephone exchanger. Also it is used in railway trains, in hospital, in laboratories, etc., and for emergency power supplies. This is the main application of lead storage battery, but it has some limitation. Question is asked also, limitation of lead storage battery. What is the limitation? Then first limitation I am telling you, the potential difference, or you can say the potential difference, or potential, simply you can tell the potential decreases with decrease in concentration of sulfuric acid. Potential decreases with decrease in concentration of sulfuric acid, already I have told you. Second, excessive discharge and quick charging shortens the life of the battery. You can't recharge quickly, you can't recharge more, and excessive discharge also, after excessive discharge means use, this life of the battery decreases, okay, shortens the life of battery. Third weakness or limitation, cell potential and the cell potential and the effectiveness cell potential and the effectiveness is reduced at low temperature. Means around 25 degree it will work nicely, more also, but at temperature is less, then this will effectiveness and cell potential will reduce, will become less, okay, at low temperature. This is the negative point. And other limitation, excessive discharge may damage the electrodes and may also sometimes it will lead to explosion. This is the important limitation, that excessive charging, you can't charge excess. Excessive charging may damage the electrode and may also lead to explosion. This I told somewhat extra things about these things, lead storage battery, okay, because it is used in large quantities, everywhere it is used, lead storage battery, hence you should know limitation also, okay. Now I am going to discuss fuel cell. This cell, actually, how does it work, that I am telling you. Fuel cell. Before understanding the fuel cell, one cell you should understand, that is the thermal plants, okay. Production of electricity by thermal plant is not a very effective method and is a major source of pollution. In the beginning, before fuel cell, electricity was produced by thermal plant. Thermal means heat. Then production of electricity by thermal plants is not a very effective method and is a major source of pollution. In such plants, the chemical energy That is the chemical energy. Chemical energy means what? Chemical energy means heat of combustion. Heat of combustion. As for example, burning of wood, burning of coal, it produces heat. Then this is called actually heat of combustion. And this heat of combustion, which is also called chemical energy, is used to produce current. Okay. Then I'm talking about the thermal plants. In such plants, the chemical energy of fossil fuels like coal, gas or oil is first used for converting water into high pressure steam. In thermal plant, how current is produced? Then first water is heated by the burning of coal or gas or oil. Water is heated strongly, it is heated and converted to the, you can say, steam at high pressure. This is then used to the, you can say, turbine to produce electricity. This high pressure steam is used in turbine to produce electricity. See, produce electricity always means production of electricity means you are just electron you are producing or charge you are producing. Charge must be flow, current must be flow. That is the intention, development of charge or development of this electron. Development of charge or development of electron. Then flow of electron is called electricity, and flow of charge is also called electricity. Then in turbine what happens? A steam is used that will rotate the blade type of things will be there. Okay. Then just like fan, three wings will be there. In that way, there this type of wings will be there. Blades, what you are telling, that will rotate very fast. That will be rotated by this steam. And any rotating things, it produce this electron. Radiation, what you are telling, it produces radiation means current. It produces current. A current means what? Electrons. Correct? That electron you can use as a current. Then here this is the mechanism. Wood or coal, if it will burn, it will boil the water, and water is heated too much, it will convert to the steam, and at high pressure steam it is passed to the turbine. In that blade will be there, just like a fan's wings, 3 wings are there. Like that way, blade, it is called blades, that will rotate very fast by this steam, and it will move very fast, and moving things produces current or electricity, or in exact way it produces electrons, and that electron it can pass through the conductor, and that current you can use for any other purpose, for lightning purpose also, the use of current. Then this happens in a thermal plant. In this process, by this method, you can produce the current. Okay. But here, what is the limitation? You should understand why fuel cell is in demand. Now you can understand. We know that galvanic cell, already I have discussed, galvanic cell directly converts chemical energy into electricity. In galvanic cell, what you are taking? Electrolytes you are taking, correct? And after this, means through the chemical reaction, you are getting energy in galvanic cell. Then this is a direct conversion of chemical energy into electrical energy in galvanic cell. Okay, that already you know that this in galvanic cell direct you can say it converts chemical energy into electricity and is highly efficient. It is now possible to make such cells in which reactants are fed continuously to the electrodes and products are removed continuously from the electrolyte component. Here that in this fuel cell, now I am talking what is happening, that near the electrodes that fuels will be sent with anode, near the cathode continuously fuels are sent, correct? And after that, this what product it is forming after the reaction, that is removed, and current produced is used. Okay, then this is the here it happens in a fuel cell, that this fuel cell, you know that fuel cell actually it is just like a galvanic cell only. Okay, then now here I told you that in such type of cells reactants are fed continuously to the electrodes, and products are removed continuously from the electrolytes component. Galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electricity or electrical energy are called fuel cells. What is the fuel cells? Now understood. Okay, that here that these things, energy of combustion of fuels here, what type of fuels? Like hydrogen gas, methane gas, methanol, etc. directly actually it is converted into electrical current or electrical energy. Then this device is called fuel cell. Okay, then galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy is called fuel cell. Here you are converting these things, energy of combustion means by burning of coal, burning of wood, hydrogen gas, methane gas, methanol. If it will burn, it will produce heat, that is called heat of combustion or energy of combustion, and that energy of combustion is directly converted to electrical energy. Then this design or this device in which that energy of combustion of fuels are converted to electrical energy are called fuel cells. Then here that in fuel cell generally what happens, I am telling you. One of the most successful fuel cell, it is of different types actually. Then one I am telling you common. One of the most successful fuel cell uses the reaction of hydrogen and oxygen to form water. You know that hydrogen and oxygen, if both will react, it will form water. Okay, then here that reaction of hydrogen will react with oxygen to form water. Okay, the cell was actually in this cell that is also called hydrogen oxygen fuel cell. This is also called hydrogen oxygen fuel cell. Then in this cell, at one electrode hydrogen is supplied and other electrode oxygen is supplied, and both will react, it will form water. Okay, actually this happens in the hydrogen oxygen fuel cell. Now actually it was used in the beginning, I am telling you, it was used, you can say, for providing electric power in the Apollo space program. When Apollo satellite was sent, that time long back around 75, before 1975, Apollo space program, there that time this fuel cell was used in that Apollo satellite. The water vapors produced during reactions were condensed and added to the drinking water. Means scientists were drinking that water, H2 and O2, which was used in this fuel cell, that was making water. Then that water was in vapor form. Then that they were cooling, means condensing, and that water was mixing with drinking water. Because in the space you will not get drinking water. Then they were carrying some water for drinking purpose, but in that water only they were mixing this water. Okay, and because it is pure water you can't drink because nutrient will be not there. That's why they were mixing with ordinary water, and that water they were drinking. Then it was solving two problems. First problem, then current it was producing. Second, drinking water for them. Okay. Then in Apollo, first time it was used. Then this they were mixing this water vapor with drinking water supply for the astronauts. The scientists were called astronauts who were going to the space. In the fuel cell, what will happen? Hydrogen and oxygens are bubbled through porous carbon electrodes. Both electrodes will be carbon only, porous. Okay, a small hole will be there. That is called porous carbon hydroxide. And after that, this their electrolyte, what electrolyte they were using? It is used in H2O2 fuel cell. Then electrodes you are knowing, anode cathode both were porous carbon. And what was the electrolyte? Then electrolyte was sodium hydroxide solution, that was used as a electrolyte, aqueous sodium hydroxide solution. Okay, then this solution actually sodium hydroxide they were actually it was solving two problems. What first was the as electrolyte, and it was you can say these things main problem main its use was as a electrolyte, main use. And this one more for catalysis purpose, purpose means as a catalyst, this thing, finely divided platinized palladium metal was used. And you can say finely divided platinum, or you can tell platinum or palladium, PT or PD metals are incorporated into the electrodes for increasing the rate of electrode reaction. And carbon, I told porous carbon was there as anode as cathode. On that platinum they used, a layer of platinum was there, or a layer of PD, palladium, that was functioning as a catalyst, and it was increasing the rate of reaction at anode and cathode. Then by this way rate of reaction was increasing by use of that is also called incorporation, or it was incorporated. The electrodes for increasing this platinum and palladium, it was, if that is in a powdered form, it was incorporated on electrodes, at the electrodes, for increasing the rate of electrode reaction. Okay. Then what type of reaction was taking at cathode and anode? Then at cathode, you know that what type of reaction will take place? At cathode always reduction will take place, and anode oxidation will take place. Then here this at anode oxidation will take place, means hydrogen gas 2H2, and here KOH, potassium hydroxide, is used as a catalyst. KOH is used as a catalyst. Then this hydrogen gas, in presence of hydroxyl ion, it produces what? It produces, you can say, 4H2O plus 4 electron. At anode 2H2 hydrogen gas plus 4OH minus, 2H2 plus 4OH minus, it was producing 4H2O, because 2H2 means 4 hydrogen and 4 hydroxyl ion. Then what will it form? It will form 4H2O, because total 8 hydrogen is there, 2H2, 4 hydrogen and 4 OH, 4 hydrogen here and 4 oxygen. Then 8 hydrogen, 4 oxygen. It will produce 4H2O, and also it will give 4 electron, because process is oxidation. Loss of electron. Then 2H2 plus 4OH minus, it gives 4H2O plus 4 electron. Now this 4 electron will be used. Where it will be used? Then it will be used at cathode. At cathode oxygen is there, at anode oxygen was there, hydrogen was there at anode. Then at cathode oxygen. Then oxygen will take this 4 electron in presence of water. Means O2 plus 2H2O. O2 plus 2H2O. O2 plus 2H2O plus 4 electron. It gives 4 OH ion. 4 OH, 4 hydroxyl ion. Okay. And this 4 hydroxyl ion it will produce. Then this is the reaction at cathode. Hence if you will add both reaction, then you will get overall reaction, net cell reaction. But here actually first reaction, that is the cathode. You can write first cathode, then anode. Why? Because to start the distance reaction, H2O also can be added. H2O also can be added to start the reaction. Okay, but it should be you can say alkaline. Alkaline means it must be mixed with KOH. It must be mixed with KOH. Okay, then this in water KOH is also there. Okay, it is the you can say mixed with KOH. KOH and water both are mixed. That's why you can write the reaction in any way you can write, not a problem, because reaction takes place simultaneously. Then at anode 2H2 plus 4OH minus, and it gives 4H2O plus 4 electron, and this 4 electron is used by cathode, means oxygen plus this 4 electron in presence of water. Water means 2H2O, it gives 4OH minus. And if you will add both reaction at cathode and reaction at anode, then you know that 4OH, it is in both side. Cathode side, at cathode also of the reaction 4OH is formed, and at anode also 4OH is there, hence both will be cancelled out. Both will be cancelled out, 4OH and 4OH, correct? And electron will be also cancelled out. Okay, then finally you will get you will get 2H2 gas plus O2 gas, and finally you will get 2H2O. This is the final reaction. H2 plus O2, it gives 2H2O. H2O is in the liquid form. Then this is actually in a fuel cell, hydrogen oxygen fuel cell. This reaction takes place. Okay, the cells runs continuously as long as the reactants are supplied. Here hydrogen gas at one electrode means at anode hydrogen gas continuously you have to supply, and at cathode oxygen gas continuously you have to supply. Both gases are fuel. And then reaction will continue. The cell runs continuously as long as the reactants are supplied. If you will stop oxygen and hydrogen, reaction will stop, cell will not work. Fuel cell produce electricity with an efficiency about 70% compared with thermal plant. Compared with thermal plant, there it was only 40%. 40% you were getting, means fuel was when fuel was converting to electricity, then only 40% it was giving electricity. But now you will get 70% electricity. Okay, then in comparison to thermal plant, fuel cell is very efficient. Okay, and because now we are getting this thing 70%, then 70% is you can say very good in comparison to the 40%. There has been this things very you can say this too much progress, tremendous progress you can tell in the development of new electrode materials, better catalyst and electrolytes for increasing the efficiency of fuel cell. These have been used in automobiles on an experimental basis. This is already used. Okay. These have been used in automobiles on an experimental basis. Fuel cells are pollution free, no pollution. In thermal plant pollution was more, but here no pollution free, and in view of their future importance, a variety of fuel cells have been fabricated and tried. Okay, and fuel cell is very, very important because hydrogen gas and oxygen gas you can get easily, and that can be converted into you can say this that can give you water also, and you will get electricity also. Hence it is good. We will get very easily electricity. Now I am going to discuss corrosion. Okay. Now I am going to discuss corrosion. Corrosion, what you actually this a type of corrosion you are knowing, rusting, 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 rusting. You know, iron rusts. Okay, in rainy season, this is rusting is common, and in industries and real life, you can say many you can say, or in any industries, maximum their plants are made from iron they are using, correct? Maximum plants are made from iron. Even the you can say flyover bridge, so many you can say these are there. They are used, they used iron they are using, particularly in industries. Big plants are there, they are made of from iron only. Flyover is also made from these things, iron. Buildings, apartment, everywhere irons they are using. Maximum you can say this metal, in the name of metal, iron is used maximum, and wherever iron is there, oxygen is there, moisture is there, then rusting will start. Then only one type of this iron rusting you are talking, but in general it is called corrosion. Then what is actually corrosion? What is the corrosion? What happens in corrosion? Then for the corrosion, what is the requirement? Then here actually process is complicated, but some basic things I am telling you. First, actually on the surface of any metal, there at any point that oxidation starts. Oxidation is responsible for corrosion. Oxidation. Then you know that oxidation is loss of electron. Any metal, not only iron, any metal in presence of oxygen, or moisture, sometimes you can tell carbon dioxide gas also. When you can say at any parts of the upper parts of the metal, when oxygen is there, carbon dioxide is there, moisture is there, then what will happen? That oxidation process will start. Means loss of electron. Metal, as for example Fe, suppose Fe is there, then Fe will lose the electron. Then who will take this electron? There must be someone to take the electron. Then I will tell you this also, who will take the electron. Then you know that redox reaction, oxidation and reduction, together it is called redox reaction. Then both takes place together. Oxidation, reduction takes place together, reduction and oxidation. then who will take the electron? Then here hydrogen ion H plus. Then you will tell from where this hydrogen came. Then this came by H2O. In air, H2O is there, moisture is there. Then actually in rainy season, moisture will be more. That's why this corrosion will be more in rainy season, because easily moisture they will get at the surface of iron, moisture may comes. Then here that H2O breaks in the H plus OH minus. H plus OH minus. Then this H plus, now it requires electron. Then this electron is taken by this H plus, hydrogen ion, and it will convert to hydrogen gas, H2. And also there is a scope to get the H plus. How? Then H2O is there and carbon dioxide is also there in our atmosphere. Then CO2 plus H2O, it forms H2CO3, carbonic acid. It forms carbonic acid. Then carbonic acid, it will ionize as H plus H2O3 minus, HCO3 minus. Okay, then this H plus also they are getting through carbonic acid, H2CO3. H2CO3 also gives the H ion, and direct H2O also it can ionize and give H plus OH minus. But only thing is that H2O ionizes feebly. H2O ionizes feebly, means very less. Suppose 100 moles are there, then 1 mole may ionize. 99 mole it will not ionize. It will in the form of H2O only. But CO2 and H2O both are present, hence they can form H2CO3, and then they can ionize as H plus HCO3 minus. Okay, it is a weak acid. H2CO3, H2CO3 is weak acid, carbonic acid. Then for the corrosion, oxidation is responsible. I think now you have understood. Okay. In corrosion, a metal is oxidized by loss of electrons. To oxygen and formation of oxide. Then what will happen? A layer of oxide will be formed. Okay, Fe will form FeO, oxides of iron, it can form, or sometimes Fe2O3 also it can form. Okay, then here that this in corrosion, a metal is oxidized by loss of electrons to oxygen and formation of oxides. Corrosion of iron, commonly known as rusting, occurs in presence of water and air. The chemistry of corrosion is quite complex, but it may considered essentially as an electrochemical phenomena. At a particular spot of an object made up of iron, oxidation takes place and the spot behaves as anode. It behaves as anode, and this we can write that actually here it forms tiny cell. Here in corrosion process, tiny cell, TINY, tiny cell, many small cell will be formed. Then where oxidation is going on, that spot function as a node, and where this electron is going to be taken, that spot is function as a cathode, and water or H2CO3 means H2O plus CO2, that function as a electrolyte. I told you for a cell always three things is required: anode, cathode and electrolyte. Then here that the spot where oxidation takes place, it functions as anode, and where the spot where hydrogen is going to reduce, means after taking the electron, H will become S2. Then that place function as a cathode, and this moisture or H2CO3 that behaves as a electrolyte. Then reaction, you can write that 2Fe that will give 2Fe2 plus 4 electron, okay, and this is the reaction at anode. 2Fe automatically it will give each Fe2 electron, then 2Fe 4 electron it will give, then it will form 2Fe2 plus 4 electron, and this time this is the this one can create potential also, because it is oxidation potential, that you can write that if we can say Fe2 in the form of reduction, if you want to write, then Fe2 plus will convert to Fe. Actually, then that time actually it is plus 0.44. Oxidation potential is 0.44. Oxidation potential means Fe is converting into Fe2 plus. But in term of reduction, you can write Fe2 plus and oblique Fe you can write, then sign will change, minus 0.44 plus 0.44. Now you can write minus 0.44 volt in term of reduction. And what will happen at cathode? Then cathode, now at cathode where that at cathode where hydrogen is there, hydrogen H plus, source of H plus is H2O or H2CO3. Then there what will happen, that at cathode oxygen will take this electron, oxygen plus 4 hydrogen, oxygen plus 4 hydrogen plus 4 electron. 4 electron came from the anode side, and oxygen and hydrogen is present at the cathode. Oxygen is available in air, and water is also present in air only. Hence you can write at cathode O2 plus 4He, 4H plus, O2 plus 4H plus 4E electron. It will form 2H2O. It will form 2H2O liquid. Then at cathode this reaction takes place. Oxygen plus 4 hydrogen plus 4 electron. 4 electron came from anode side. Then it will form 2H2O. And in this process means when this will convert to H2O, H plus will convert to H2O, means H plus oblique O2 oblique H2O. Then this time it will be plus 1.23 volt. When H plus convert to H2O in presence of oxygen, it will produce 1.23 volt. Okay. Then overall reaction, add both anodic reaction and cathodic reaction, you add. Then you will get left side you will get 2Fe plus O2 plus 4H plus. 4H plus. 3 things you will get in left side. 2Fe plus O2 plus 4H plus. All are in aqueous. Fe is solid. Oxygen is gas. 4H is aqueous. And product side you will get 2Fe2 plus, that is in aqueous, plus 2H2O. H2O is liquid. And overall voltage it will produce 1.67. 1.67 means 1.23 and 0.44. It will give 1.67. The ferrous irons are further oxidized by atmospheric oxygen to ferric ions. It will not stop only by giving 2 electron, Ap becoming Ap2 plus 2 electron. Further it can oxidize. Ferrous ions are further oxidized by atmospheric oxygen to ferric ions, which comes out as rust in the form of hydrated ferric oxide, Fe2O3. Hydrated ferric oxide means what? Fe2O3. Fe2O3 means Fe is plus 3, oxygen is 2. Cross Fe2O3 is cross vacancy. For the oxygen is 2, Fe2, then this 2 is for oxygen, and FeO3, then this 3 is for iron. Here iron has oxidation state plus 3, oxygen is minus 2, correct? Then Fe2O3, and it absorbs water, XH2O, X maybe 1, 2H2O, 3H2O, then Fe2O3 XH2O, that is called hydrated ferric oxide, and its color is brown. Okay. Then this is actually rusting material. This is actually rusting material. This is the rust actually. It comes out as rust in the form of hydrated ferric oxide, and with further production of hydrogen ions. Okay, and again hydrogen ion it can produce. Here I want to tell you one more. You might have seen black rust also in old building. In old buildings near the road you will find black rusting. What is that? Then that is the Fe3O4. Fe3O4 ferroferric oxide. Question is asked. It is very important question for advance. Iitjee advance, that black color, for the black color of rust, it is what type of material is this? It is due to which reaction? Then now this is due to the formation of Fe3O4, ferroferric oxide. Ferroferric oxide. Then what is this ferroferric oxide? Fe3O4, how does it form? What is the oxidation state of iron here? Then you will think that it is Fe3O4. Then Fe will be plus 4, oxygen will be minus 3. You can think like that, but it is 100% wrong. Then what is correct? Then correct is that it is the mixture of FeO plus Fe2O3. It is the mixture of FeO plus Fe2O3. Means here you will get Fe plus 2 also and Fe plus 3 also. It is a mixture of both FeO plus Fe2O3. Okay, this question is very, very important. Then now further I am going to discuss protection. How will you protect? Then ferrous irons are these things, prevention I am talking of. Already I told this thing, conversion, that prevention, how will you prevent corrosion? Prevention of corrosion is of prime importance. It is not only saves money but also helps in preventing accidents such as bridge collapse or failure of key component due to corrosion. One of the simplest method of preventing corrosion is in this. What to do to prevent? Then you have to just prevent the surface of metallic object to come in contact with atmosphere. Means if you will not allow, if on the surface of the matter, if atmosphere is not coming in contact with the metal, then corrosion will stop, because for that atmosphere is important. But atmosphere, how will you stop? They will come in contact with everything. Then how will you prevent metal from atmosphere? Then for that, one coating is required. Actually, in Deepavali time, you know that painting will be there. Painting. And that painting, that will behave as a barrier between metal and atmosphere, or wood and atmosphere. If it is wood on wood door and other things also, you are putting paints, different type of paints. Then particularly for metal I am talking here now. Then on metal also one prime is that is a first coating will be of a prime, one solvent will be there, and after that paint will be there. Some paints you are putting. Then these paints actually keeps distance between metal and atmospheric air. Atmospheric air will not come directly to contact with the surface. Then process will stop. Okay. This is the very just easy method, and peoples will do like that only. Okay. Means you want this preventing corrosion. Then preventing corrosion is to prevent the surface of the metallic object to come in contact with atmosphere. This can be done by covering object to come in contact with. This can be done by covering the surface with paint or by some chemicals. As for example, bisphenol. Bisphenol is a chemical. If you put a layer of bisphenol on the surface of metal, then it can keep distance. Means atmosphere can't come in contact with the metal. Okay, metal articles. Another simple method is to cover the surface by other metals like Zn or stannous. What will it do? Actually, this is very important things. Question is asked. First method is common, everyone is using. Another simple method is to cover the surface by other metals like stannous or Zn that are inert or react to save the object. How it will save? Then Zn actually in comparison to the iron or any other metal, Zn oxidizes fast. When air will come, suppose one layer you have put for Zn, or that metal is joined with Zn rod, suppose, then what will happen? That if any you can say this air or moisture will come in near the metal, then before reaching to the metal, it has to pass through Zn. Suppose one layer is there for Zn, then they have to come in contact with the Zn. Then Zn will sacrifice for iron or for other metals. It will sacrifice. Just like you can say security person. If any persons are coming to want to enter the office, this, that, then this security person will not allow, they will fight. Sometimes that they can die also to save their, you can say their master or their owner, they can die also. Then like that way here, Zn will fight with that oxygen and carbon dioxide, these things. If one layer is there for Zn, then it will oxidize first. It will oxidize first, means Zn will convert to ZnO plus Zn. You know that oxidation Zn will give Zn plus 2 electron, means Zn will convert with oxygen, react with oxygen, and it will convert to ZnO, zinc oxide. Then first all atmosphere they will fight with this Zn. Zn is now reacting with this atmospheric air and moisture. They are fighting Zn, and that metal is now saving. It is saving the metal. Until Zn is there, that metal can't be reacted. It will not react. Atmosphere will not come in contact with the metal until Zn layer is there or Sn, stannous layer is there. That's why it is put one layer of Zn, or Sn. Sometimes there in boat they will, because boat also sometimes they will use the metal they will use sometimes. On wood they will put some metal, then it has to save the metal boat. Then there in every boat they will put a rod of Zn, so that before going to the metal they will come in contact with the Zn, because Zn can easily be oxidized. Then until that Zn or stannous will be there, that can be, they can't react to the metal. Hence this is called sacrificial anode. This is called sacrificial anode. Question is asked. Okay, then this I told you that Sn or Zn, these metals protect this Zn and Sn, stannous or zinc, protect the others metals. Okay. An electrochemical method is a third method I am talking about. An electrochemical method is to provide a sacrificial electrode of another metals like magnesium and zinc. Magnesium is also used. Okay, that is called sacrificial electrode. What I told you now, same way. Okay, that is this is electrochemical method. Is to provide a sacrificial electrode of another metal like magnesium or zinc, which corrodes itself, but save what will happen? But save the object. It will save the object. Okay. Then this I have told you about the, you can say, corrosion. Corrosion actually is very you have to tackle the corrosion tactfully, otherwise not only money will be destroyed, it can destroy the life also. In rainy season, if flyover will, you can say, fall down, then what will happen? Many times it happened. If building will collapse, flyover will collapse, apartment will collapse, bridge will collapse, then what will happen? Not only there will be loss of money, loss of life also. Hence, corrosion is very important. And actually, in all over the world, this is a big problem, very big problem. And this corrosion is always wherever iron is going to be used or metal is going to be used, then they will put some, you can say, sacrificial anode. Even a costlier instrument in lab, even you can say, if dust will enter inside the instrument, then when dust will enter, then with the dust air will also go, and in the corner they will collect dust where your hand can't reach, you can't clean. Then if more dust will be, you can say, collected there, then there pits will be formed, pits, corrosion, also called pits corrosion. Then with the dust air will go, and with the air moisture will go. Then there what will happen? Again same thing will happen, because air is also there, moisture is there, and in a corner many dust is there. Then with the dust, air and moisture went, then corrosion may start there. That's why costlier instrument also can be rusted and can be corroded. Hence, one should be very, very careful, because even a small, if it starts corrosion also, instruments will stop working. Hence, one should be very, very careful when you are using any metallic substance. Now, I have finished complete this chapter, electrochemistry. I have finished. It was a very, very important chapter. I have finished. Many questions is asked from this chapter, theoretical and numericals also. Now you have to prepare nicely. Any question now you are in a position to solve any question by use of only these concepts. Okay, only question you have to understand. And now I am stopping only here. Next class I will start with new chapter. Thank you.